Okay, so for today's lesson, we are going to learn how to make two different types of graphs, stem and leaf plots, and histograms. Again, both of these are for quantitative data. Last time we did dot plots, I believe. Okay, so stem and leaf plot, probably something you saw in middle school. The left digits are the stems. The right digits are the final digit or the leaf. Stems are ordered from least to greatest. We're very particular about that. They're from increasing order from left to right. Provide a key that explains what the stem and leaf represent. So this is key. Okay, so this one, Mr. Tyson asked his students, so I thought they would show us an example first. They did not. So this is all the data, 4.87. 5.02, so we have to maybe make a stem and leaf plot of this data. So it's not going to be super easy to do. So I think you actually have to, the last digit, the number on the right is going to be the last digit. So for example, for that first number, 7 is the number on the right, 48 is the number on the left, so to speak, of 4.87. So I think you're going to have to make stem and leaves. So the stem is going to have to be 48, 49, 50, 51. So do you see the data again? So look at that. So like for 487, the digit on the right has to be 7. So there's 2 digits on the left, so 48. So for the next number, 5.02, it's going to be 50 and then a 2. 49 and then a 7, 49 and then a 2, 50 and then a 3. So I'm reading the first 2 digits together, and the last digit is the digit on the right. So the stems will be 48 through 52, because I think all the numbers start with either 4.8 or all the way up to 5.2. There's nothing bigger than that, so that's okay. On the right are the leaves, and so each one of those numbers on the right is it's part of the decimal point. So like the very first digit there is 4.87. So if you look at the first, I'm kind of pointing to it, and I don't know if you see my pointer there, but the 48 is on the left on the stem. And you see that 7 on the right? So that number means 4.87. So the key says this, 52 bar 4, or the stem is 52, the leaf is 4. That means the number 5.24. So like at the biggest number there would be 524, so 5.24. The second biggest number would be 5.20, 5.18, 5.15. So you've got to kind of get used to that and do that. Describe the shape. So on this one, I wish I could turn the screen, let's see, counterclockwise, 90 degrees. If you do that, you would kind of see the shape looks to be skewed to the right. It's kind of going to the right or towards the bigger numbers. The possible outlier would be 5.24 or 5.2 might be outliers potentially. So this is definitely skewed to the right. Again, if you kind of tilt it, turn it 90 degrees counterclockwise, it kind of has the look of a skewed to the right or skewed towards the larger numbers there. If you kind of draw it and turn it sideways, you can kind of see it there. So sometimes it's important to split the stems. If you have like too much data in one column, one row, I guess, that'd be bad. So that's what maybe the normal plot would look like potentially there. If you split it, you might have a better view of the distribution. Now it looks a little bit more potentially skewed right than it did before. So it had more of a symmetric look to start with. And I'm concerned about that. I guess that would be 25.6 there number. Looks to be an outlier, which makes me think it might be skewed to the right. So it could change the shape potentially a little bit if you split the terms. It's not always necessary to do, but you can do it. So what they did when they split the terms, I don't know if you caught that, but they're taking like the first, there's two 21s there. The first 21, the leaves are all 0 through 4s. The second 21, the leaves are all 5 through 9s. Same thing for the 22s. The first one's 0 through 4s, the second one's 5 through 9s. So they're kind of splitting it somewhat in half-ish, so to speak, there. So you see for 23.1, whatever there. Those are all the 0 through 4 endings or leafs there are the first one, and all the 5 through 9s are the second one. You can round or truncate. That's okay to do sometimes. Truncate means to cut it off without worry about rounding. 7-leaf plot shows every individual data value. The only other graph that shows that is the dot plot. So dot plots and 7-leaf actually show every single value, which is kind of nice. What's a histogram? So we're already in histograms here. So a histogram is a graph of the data for one quantitative variable that displays each interval on the horizontal axis bar. The height of each bar shows the frequency or relative frequency of all the data. So this is for quantitative data. So sometimes we organize it take that quantitative data and kind of group it into a bar, kind of like push it into bars. Especially when we have a large quantity. That's really when we use it. Okay, the teacher asked the students to record how many U.S. states they have visited. Driving through a state counted, but flying over one did not. Unless they landed in the state, that would count. Here are the responses of the 30 students. Okay, so all the way from 5 to 31, I kind of like that they seem to organize it somewhat by, in this case, descending order, but that's nice for histograms. So you have to kind of choose an equal length intervals. So they went by 4s, 4 to 8, 8 to 12, 12 to 16. That has to be consistent through all of it. So they tried to not have so many different bars. That'd be a crazy bar graph with that many bars, too many, right? So it's going to be called a histogram, kind of pushing those bars together, and that's what it looks like. So what this means is first bar there, that 4 through 8, there were 2 items that were between 4 and 8. I think 5 and 5 were those 2 items. There were, 11 data pieces that were between 8 and 12. So you can count it out. That's true. So forth. That looks like it's maybe skewed to the right. Can you use the graph in part A to justify the claim that most of the students have visited fewer than a dozen states? So it looks like 2 plus 11 is 13. So how many students are in the class? So there's 30 students. So 2 plus 11 is less than half. Oh, well, 2 plus 11. So fewer than a dozen. No, not fewer than a dozen. There's going to be 11 plus 2 is 13, right? So 13 out of 30, which is 43%. Because so we cannot use the graph to justify the claim that most of these students have visited fewer than a dozen states. So it's way less than 50%. 43% have done that. Because a histogram does not show individual values, which is different than like a dot plot or a stem and leaf plot, we can only give estimates of the center and variability. That's true. But it does a really good job on shape. So histogram we really like for the shape. It's kind of its purpose. So this book includes the left end as an endpoint and not the right end. So in other words, like when you read this 4 through 8, that would be read as 4 including 4, but not including 8. The next bar would be including 8. 8's go in the second bar, but not including 12. Any 12s would go in the third bar because it includes 12, but not 16, etc. Okay, that's it. That's your whole lesson for today. Thanks.